Welcome to Permutations and Combinations Critical Problems. This is part 2 of the video. Okay. In this video, we will learn the concept stars and bars or balls and bins. Okay. And this method we will learn and we will solve some problems. In the previous video, we have learned a concept different objects in the identical baskets. Okay. Different objects in identical baskets. That is the concept we learned, and also we learned identical objects in identical baskets. Okay, in this one we are learning actually stars and bars is nothing but identical objects in different baskets. Okay, so this concept we'll learn. Let's see. First we'll learn the concept. Okay, this is called stars and bars or balls and bins and a few other names also there. Okay, distribution concept. What this as a tells is, by example, let's understand. 5 balls, all balls are identical, are to be put in 3 bins, and these bins are numbered 1 to 3. Okay, these bins are numbered 1 2 3. How many ways we can put? And each bin may get anything from 0 to 5. Okay, it can get nothing, it can get all possibilities are there. Okay, this is the concept. So if you understand, let's say uh, call this balls, I will equate this balls to stars. Okay, and the bins to bars. Okay, so something like all balls are stars and all bins are bars. Okay, so this is same as 5 balls can be put in 3 bins as shown below, right? Okay, 2 stars means 2 balls. Okay, 2 stars in 1 bin. Okay, that's why there is a bar separation, and the 2 stars in second bin and 1 star in third bin. I can separate it like this using 2 bars. Okay, so if anytime you are asked so many identical objects to be distributed into uh, n number of bins, then you need n minus 1 bars. Okay, one less than that, right? So that you will create 3 spaces or n spaces basically, correct? So if I represent it like this, this means 2 in first bin, 2 in second bin, and 1 in third bin. So that we will represent as 2 to 1. Okay, this is one possibility, one of the possibility. Okay, it can be anything like this. Okay, many more possibilities are there. Something like if I put it like this, bar and 5 stars, then it means 0 0 5. Okay, so first bin has 0, second bin has 0, and third bin has 5 stars. Okay, so this is the representation. Now if you understand how to solve this problem, right, very simple. Okay, I have 5 stars here, correct? If you understand clearly, there are 5 stars and 2 bars I should place in between. Anywhere, it can be anywhere. So how many places I have? I have total of 7 spots, right? 5 stars and 2 bars. Total 7 positions, and I can put my 2 bars anywhere in that. Anywhere in that 7 positions. Correct? So this is nothing but 2 bars can be placed among 5 stars in same as, okay, 2 bars can be placed in any 7 positions. 5 plus 2 basically. Okay, so which is nothing but 7C2. Okay, which is 21. 21 ways I can place. And how this 7 and 2 came? 7 came from 5 plus 3 minus 1. Okay, C 3 minus 1. Okay, 5 plus 3 minus 1 C, 3 minus 1. Okay, so this is the combination I am looking at, and this means 21. So these bars can be placed anywhere in the 7 spots in 21 ways. Okay, so this is what we should understand. Okay, once you understand this, the problems are very simple. Okay, concept is very clear, and when to apply what is very important. Okay, when you are applying this is very, very important. Okay, so this is the concept of stars and bars. Let's do some problems, then you will understand more about putting identical objects in uh, different bins. Okay, so the number of ways in which 21 identical apples can be distributed among 3 children such that each child gets at least 2 apples. Okay, so if you see this one, it is very clearly this is a straightforward question of stars and bars. You have 21 identical objects, and the bins are nothing but the children here. So 3 different children, right? So how many ways you can give? And each kid should get at least 2 apples here, not 0. Okay, the stars and bars we learnt is if each one is greater than or equal to 0. Okay, either they can get 0 or up to maximum of complete, right? So first thing is give two apples to each child. Okay, out of 21 apples, give 2 apples to each child, which means 6 apples we are giving to the 3 children. correct? So we are left with 15 apples, and these 15 apples can be distributed among the 3 children in any way we want. Okay, you can give all 15 to one child or 0 to the same child. Okay, so you can do whatever you want. This is exactly the stars and bars problem now with 15 balls and 3 children are there, so 2 bars, correct? So 15 apples can be given to 3 kids. Okay, this is how many ways you can give? 15 plus 3 minus 1, that is 2. 15 plus 2 C 3 minus 1, which is 2. Okay, 15 plus 2 C2, which is 17 C2, that is 136 ways you can give. Okay, so hope you understood this stars and bars application. Okay, this is how you can use, and simply stating this, we can also say this way: x plus y plus z equal to 15. How many ways it is possible? And x y z are integers, positive integers. Okay, which means x y z are greater than or equal to 0, correct? So this is exactly same problem as that: x plus y plus z equal to 15. Okay, the answer is same, 136 ways it is possible. X y z values are 136 ways it's possible. Okay, if you call them a ordered pair, then ordered tuplet, then 136 tuplets we can make. Okay, hope you understand this. Let's see the next problem. Number of ways of arranging 8 identical books into 4 identical shelves where any number of shelves may remain empty is equal to. Okay. So if you look at what we have to do is you have to uh, put 8 identical books in 4 shelves. Okay. So each shelf can have 0 to 8 any number of books. Okay. This problem looks very similar to the stars and bars problem. Correct. So can we solve it that way? Okay, look at the problem carefully and then decide. Okay, so if you see here, the difference is here there are 4 identical shelves. Okay, so this is not exactly the stars and bars problem. Okay, this is 8 identical books into 4 identical shelves. Okay, stars and bars is you have identical objects put in different bins. Okay, here bins are not different. Okay, so this is different. Okay, this is a simple counting problem. Okay, so we should be very carefully understand where to put stars and bars application. Okay, since shelf can be empty, we need to put 0 to 8 numbers to each shelf. So this problem can be easily solved, a counting problem. So just make a table and make sure that you don't repeat the numbers in the shelves. Okay, okay, the books and shelves both are identical, right? So we need to partition carefully. How we can do it this way? So always starts with the maximum. Okay, maximum in one shelf, that is 8000. Now you don't need to worry about 0800 because all 4 are identical shelves, correct? So the distribution is same. Even if it is 0800, 8000, all are same, both are same. Okay, so you don't need to repeat that combination again. So 8000, 8000, and then you reduce 1, go to 7, and how much is required? 1. So that's it. This 1 can be anywhere. Okay, all are same. So 7 1 is other option, then 6 2, 6 1 1. Okay, then always make sure that whatever number you are decrementing here, and the second number should not be greater than the first number. This is most important. Okay, otherwise you will go into wrong placing, and then you will get a wrong answer. Okay, 5 and 3, right? 3 is the maximum, right? Second one. So this is 5300, then 521 and 5111. Okay, this is how we should do. Then 4400, 431, 422. Okay, then 4211. Okay, and 4111 is possible? No, that's not possible. We have 8 books in total. So this is the last combination with 4. Then 3, then don't take 4 here. Okay, this is already covered. That's why I'm telling. Your second row should be always less than or equal to the first one. Okay, so 3 4 is covered here. You don't need to worry that. Okay, so 3 3 2 or 3 3 1 1. Similarly 2 2 3 1. Okay, okay, you can take 2 2 3 1. Okay, because here I am telling don't take the 3 here. Okay, don't take that possibility. Okay, so 2 2 3 1, and actually this should be covered under 3 2 2 1. Okay, it should be covered under that. Okay, so write it properly. The last one is 2 2 2 2. Okay, is there any other combination possible? No, there is no other combination possible. So this total is 15. That is the answer. So carefully differentiate your problem, which is stars and bars and which is not stars and bars. Okay, so what we learned so far is, okay, we have a stars and bars problem where objects are indistinct, bins are distinct. Okay, in distinct into indistinguishable bins, okay, objects are distinct and bins are indistinct. Okay, and in identical objects into identical bins, both are identical or indistinct. Okay, now approach is stars and bars, we have combinatorics. Okay, we have a formula for that one, n plus k minus 1 c k minus 1, where n is number of stars, k is number of bars. Okay, k is number of bins. Okay, now for this one, distinct into indistinct, we have a method, but counting is the easier method. We have a Stirling number of second kind. Actually, this formula you can apply if you understand, but counting is fairly possible. Okay, and identical objects into identical bins, there is only counting partition. Only counting is the only method you can solve the problem. Okay, and the fourth one is there, which one is uh, distinct objects into distinct bins, which is what we normally apply our combination, permutations and combinations problems. Okay, so these are the four types. Okay, carefully distinguish where your problem is falling. Okay, so let's do one more. The number of triplets XYZ where XYZ are distinct non-negative integers satisfying x plus y plus z equal to 15. I told you in the previous example once, the problem can be converted as x plus y plus z equal to some 5, right? 5 balls, or 20 apples can be distributed to 3 kids. So this is exactly same. So this is also stars and bars problem, correct? So x plus y plus z equal to 15 means 15 can be distributed to x, y, z, and it is non-negative integers, correct? Non-negative means 0 and above. So simple stars and bars problem. Okay, 15 plus 3 minus 1, because xyz 3 variables are there, right? So 15 plus 3 minus 1 c 3 minus 1, which is 17 c2, which is 136. Okay, if you stop at this point, okay, this problem is correct. Okay, but only thing is there is a word here, distinct non-negative integers. Okay, so because of this one, this is exactly 136 is not the answer. Why? Because what is trying to tell is x and y cannot be equal, x, y and z cannot be equal, y and z cannot be equal. Okay, so this is what is trying to tell. These integers x, y, z values should be distinct, so we have to subtract all the identical, I mean, if x and y are equal, that condition we have to separate. Okay, how can we do that? That also we can use a stars and bars method and solve it actually. Okay, how we will do? Let's do it here. Okay, so check the case x equal to y. When x equal to y, what happens? It is the equation is simply 2x plus z equal to 15 or z equal to 15 minus 2x, correct? So we have a possible solutions for x. Easily we can easily identify how many solutions are possible. Okay, x equal to y or x equal to any of the values 0 to 7, you get distinct different z, correct? So there are 8 possibilities where 0 to 7, there are 8 possibilities where x equal to y is possible, and this is same as y equal to z, this is same as z equal to x, correct? And x equal to y equal to z, there are 5 possibilities are there. Okay, total 8 solutions, including this 8 solutions include this 8 solutions includes x equal to y equal to z also. Okay, now similarly we get 8 solutions for y equal to z and 8 more for x equal to z, and all the 3 includes x equal to y equal to z, so you have to remove the repetition there, correct? So 8 into 3 minus 2, 2 repetition of x equal to y equal to z equal to 5, this should be removed. So 24 minus 2, which is 22. So total possible solutions are 136 minus 22, which is equal to 114. Okay, so carefully read the question, whether he is expecting a distinct non-negative integers, okay, or anything. If it is simply, if it is not stating distinct here, if this word is not there, if x, y, z are just simply non-negative integers, the problem ends here. The answer is 136, but he said distinct non-negative integers, so we have to continue it, remove all the equal solutions, right? X equal to y, y equal to z, z equal to x, and then all 3 are equal, all combinations you have to remove. So answer is 114. Okay, next. Yeah, next question. The number of ways to distribute 30 identical candies among 4 children C1, C2, C3 and C4, so that C2 receives at least 4 and at most 4 candies, C3 receives at least 2 and at most 6 candies is equal to. So this is also stars and bars problem. Only thing is there is a condition set and the condition is different for different variables, correct? So previously we have seen similarly distributing some n candies to 4 children with at least 2 each, correct? So all the condition is same for all children. So it was easy to just give out the 2 candies before and then the only remaining candies you distribute among the 4 children. That's what we tried. But here uh, C1 and C4 have no condition. Okay, they will get either 0 or all. Okay, but whereas C2 and C3, C2 can get only 4, minimum 4 and maximum 7. C3 minimum 2 and maximum 6. Okay, so let's see how to do this. This is simple. First, give the minimum candies to C2 and C3 and then find out total combinations. Now that includes more than 7 for C2 and more than 6 for C3, correct? So remove those conditions. Remove those conditions, then we are done. Okay, so let's see how to do this. Okay, this is a stars and bars problem only, but we need to apply it many times. Okay, so given condition is C1 plus C2 plus C3 plus C4 equal to 30. Condition is C2 is between 4 and 7 inclusive, C3 is between 2 and 6 inclusive. So first let's give out 4 and 2, 4 to C2 and 2 to C3. How can we do that? Let's take another variable, C2 equal to C2 dash plus 4, C3 is C3 dash plus 2. Okay, whereas now the condition is C2 dash is between 0 and 3 and C3 dash is between 0 and 4 because I am removing 2 from the C3, right? And 2 from C3 and 4 from C2. Okay, now my new equation looks like something like this, C1 plus C2 dash plus 4, C3 dash plus 2 plus C4 equal to 30. If I simplify, this will become C1 plus C2 dash plus C3 dash plus C4 equal to 24. Now this is a stars and bars problem, but remember this don't have limit on the upper limit is not considered yet. Okay, so this is not complete solution, but let's find out with this equation how many possibilities are there. So with this equation 24 plus 4 minus 1, because C1, C2 dash, C3 dash and C4, there are 4 variables here. C4 minus 1, which is 27 C3. Okay, so note down this one. Then now go to the upper limit of individual one. Okay, let's consider C2 dash should be less than 3, right? This is the condition. Consider the upper limit, C2 dash should be less than 3. So let us consider all cases where C2 dash is 4 and above. How do we do that? Let's take one more variable, C2 dash equal to x2 dash plus 4. Okay, so which means I am considering all cases where C2 dash is 4 and more, correct? Right? So this is not a possible combination, we should subtract it. Okay, so how can we do that now? Now you take again the equation C1 plus x2 dash plus 4 plus C3 dash plus C4 equal to 24. Right? I am just using this equation, and C2 dash I am replacing with x2 dash plus 4. So this is nothing but C1 plus x2 dash plus C3 dash plus C4 equal to 20. Again using stars and bars I will get the solution as 23C3. Remember, this is I am trying, if I subtract this one, okay, this does not remove just C2 dash, it actually has some more C3 dash more than upper limit also is considered here, correct? C3 dash upper limit also considered. So we will subtract once again. Okay, though it is a repetition, so we will subtract again. Okay, so now continue and consider the upper limit for C3 now. C3 should not be should be less than 4. That means I will consider C3 dash as x3 dash plus 5. This is, it should not be more than 5, right? So I will consider this case and subtract this. So again substitute C1 plus C2 dash here, sorry, C1 plus C2 dash plus x3 dash plus 5 plus C4 equal to 24, or C1 plus C2 dash plus x3 dash plus C4 equal to 19. So this is again 19 plus 4 minus 1 C, 4 minus 1, which is 22 C3. And remember, this includes C2's upper limit again. Okay, includes. No, I am not subtracting. So now you consider upper limit for both of them, and then C2 dash should be less than 3 and C3 dash should be less than 4, correct? So C1 plus x2 dash plus x3 dash plus C4 equal to 15. I am removing both upper limits. Okay, so I will left with 15 here. Now this again apply stars and bars, you will get 18C3. Okay, so this 18C3 was already considered in this 18C3 is already considered in this as well as the previous condition, right? Upper limit, previous upper limit here. Okay, so in this also 18C3 was considered. So what we should do is simply it is 2 times subtracted, so you just add this. Okay, so number of solutions is 27C3. This is how the numbers you got just now. Okay, this is the total, subtracting the upper limit for C2, upper limit for C3, and then repetition I am adding. Okay, I mean 2 times I subtracted for upper limit of C3 and C2 here, so I am adding that here 18C3. Okay, so the answer is 430. Okay, hope you understand this problem. Okay, this came in JEE Mains 2022. A very good problem, real application of stars and bars. If you understand this problem, okay, repeatedly do this. Okay, you can solve any stars and bars problem very easily. Okay, this has all the conditions applied here. Okay, individual conditions are there. Okay, yeah, hope you understand the stars and bars concept using this video. Let's solve more problems. Keep watching my channel, and especially the shorts where all the easy problems are made as shorts. Okay, thank you.